All right. Good evening, everyone. It's a pleasure to again, start our session on a Tuesday evening. Tuesday evening, at least in Singapore. And it's a pleasure to have one of my MVP colleagues, Ben, Dr. Ben,
All right.
who has
Good evening,
been
everyone. It's a pleasure to again.
working on Jupyter Notebooks. He was doing it for one of the clients, and I really found his approach very, very interesting. So I thought, why not have him come over and share his knowledge with the rest of the community? So over to you, Ben. All yours.
Thank you very much, and thank you very much for inviting me. I'd like to say, first off, if there are any questions, if you just type them in the chat window, and Situ and I agreed that he will monitor the chat and notify me if there are any questions, because I'm not very good at monitoring a chat window while I'm presenting and showing stuff and browsing code. So I'm not that much of a multitasking guy, but I'll try my best to answer all questions. And please feel free to ask questions anytime, because I'm always happy to have a lively discussion during presentations, because I think this makes it more interesting and increases the outcome for all of us. So let me start straight away, and I'd like to start with a disclaimer. I'm about to talk about running Jupyter Notebooks in a production environment. Is this a good idea? Certainly not. I would not recommend to run a Jupyter Notebook in a production environment. I just want this to be very clear. This is not, Jupyter Notebooks are not made for production environments. I'll talk a bit more about that in a moment. Will I do it anyway? Definitely. And do I have a reason to do it? Yes, I hope so. And I hope that I can make you see the reason why I did what I'm going to show to you. What I did here comes from a customer project. All of this has been tested with the customer, and this is more or less the condensed results of what I did for my customer. I included, and this might not be necessary here, some basics for non-data scientists, because I gave this presentation at a SQL user group the other day, at a data platform user group. So I think that we can keep this very short. You all hopefully know that notebooks, and that's the key point here, are more like interactive work, embedding code and results and documentation and everything. And what I've seen them used for with most of my customers is more like an explorative way and wrangling data, and usually executed by the data scientist or by someone who works with the data on their local machine, on their local infrastructure, and not on a server and production environment. And the consequences is that since the Jupyter Notebooks contain visualization and result sets and documentation and code, they can become quite large. Many of you will probably have noticed that already. And because they're an interactive means of working, they're often not production ready, or usually not production ready. What I mean by that? By that I mean that usually at least when I work with Jupyter and when I create a notebook, I have cells in there where I experimented with things that throw errors because things didn't work out the way I wanted, that are left over from previous attempts, that are copy and pasted from other notebooks where I tried to adapt things that won't compile, that won't run, and all these things are in there. And that's usually something that you do not want to happen in a production environment. Plus, if you can access a database from your Jupyter Notebook, you can do on that database whatever permissions you have. So also here, it's necessary to be rather careful when we're talking about permissions. So this is kind of a warning that if you're trying, I'm not saying don't try this at home, but if you try this at home, be a bit mindful of the consequences of what might happen and who you give permission to do what in which environment. And this is very important, because usually the experience I have made is that people who work with Jupyter Notebooks and people who have security concerns and work with databases are separate people. And if you want to bring a Jupyter Notebook into production, you need to combine both mindsets a little bit. So it's important to bear that in mind, and to bear in mind that it's important to also have the mindset of the data engineer, of the DBA with their security concerns if you're doing what I'm showing you. Okay. I asked, and this is where this all started, how to transfer code or Jupyter Notebooks to production. And maybe Situ remembers, I asked this question on the mailing list, and the answer generally was, well, it's fairly simple. You just take a notebook and you take the code out of there and you rewrite it to be production ready, and then you deploy it using such and such solution. And of course you can do that. But if you want to go that way, you will need someone who understands the code that's written, the data scientist. You'll need some developer who can transfer the code to a deployable form. And usually, most of the time, these are two different people because they have two different views on the code and two different views on the data. And you need some operations guy to handle the deployment, to handle delivery of this code, to handle monitoring and stuff like that. And this is where a lot of the trouble comes in. But before I talk about the trouble and why we chose the approach that we chose, I would like to introduce myself, because I didn't do that so far. I just jumped in right with the heavy stuff. So as a short introduction, I am from Berlin. So here it's not evening. Here it's a beautiful sunny noon right now. I'm CTO and co-founder of MLPA Consulting. We're consultancy working almost anywhere in the Microsoft data platform with a very strong focus on IoT projects. Very, very long ago, I did a PhD in applied mathematics. So I did things like partial differential equations, solvers for partial differential equations, stuff like that. Since this summer, I'm a Microsoft MVP, and it still feels a bit strange to say that, but here you go. I am leader of our local path chapter here in Berlin. And since I like to add a personal and private note, if you've seen, I don't know if you can see my camera, I think so. And then you might notice that I'm a bit of a music nerd and a data nerd. So let's go on with the project. The basic question was, we have these Jupyter Notebooks that the data scientists achieved, and how can we get them to production without blocking our developers? And the trick here is that the customer has two data scientists, two people working on Jupyter Notebooks, but only one developer and no ops guy, so that has to be handled by the developer as well. And that means two data scientists continuously improving their notebooks and continuously working on their notebooks have the ability to block one developer entirely. And that's not good for the overall project. And that's also why manually transforming the notebooks is not an option for this use case. So the next thing I would like to do with you, now that I've stated the problem, and now that I've explained why I'm doing what I'm doing, even though I know that it's not necessarily a good idea, I would like to go through the process of what I'm doing with you. First in a schematic way, and later we'll look at code. So I hope no one here is scared of code today. If you are, I'm very sorry. But it's not much code. It's 150 lines of code that we could condense down to, say, 70 lines of code. So it's manageable, okay? So let's talk about the process. My process looks a bit like this, and I'll explain it to you in a moment. The first thing is, data scientists write Jupyter Notebooks. Okay, so we have our culprit. We have the object of our desire that we want to work with. Second, what needs to happen is we need to commit it to a new branch in a special Git repository. That's an approach that I chose. There are many alternatives that you could think of, but that's what I chose. What that means is, in order to keep our file size reasonable and to keep our commits in a reasonable range, that means that we want to strip all the results from the notebooks and just commit the text and code cells and not the results. Also because the results might include sensitive data and you don't want to commit sensitive data into your Git repository. I chose to pick a new branch for every repository. You could choose for every notebook. You could also choose as an alternative to have a new repository for each notebook, or have a combination of repositories and branches. I might switch to that later, but at the moment I'm working with a new branch for every notebook in one Git repository. And you'll see in a moment how to change that, how to work with that, and how this would be able to adapt. So the next thing that happens is some action, some daily load, whatever, triggers an Azure function. This Azure function, as you can see in the image, is like at the heart of, at the very core of the entire process, okay? So this function is triggered, for example, by a daily load and says, okay, I want to evaluate all the data in today's data load. I want to run a machine learning model on all new data in a certain table or stuff like that. So this is what triggers our notebook execution. So it's not magically, but it's automatically. We want it automated. We want a notebook. As I said, scenarios will be, I want to run a model to evaluate every row in a new table, stuff like that. What happens next? The function wakes up, and when it's triggered, it also gets passed an execution ID. I'll talk about the data model later, so don't worry about that yet. I'll show it to you. I'll get into the nitty-gritty details in a moment. But what this function then does is it goes to the database and finds out meta information about the notebook. For example, which branch of the Git repository it's in, and what parameters do I need to run it with. Next step is I pull the notebook, and I forgot to mention that before. Together with the notebook, I ask the data scientists to add requirements TXT to the Git repository to the branch for each notebook, so that I know which dependencies I need. So I pull the notebook and, if available, the requirements, and pull them onto the host of my function. Now, my function host is basically abandoned after each execution. Functions, if you don't know them, are means of serverless computing. And I don't have a computer that I work on as infrastructure bit, but I have a host that I don't really have access to, but I can access it, of course, in my code. And I'll show you in a moment how. Next thing is I go ahead and install the requirements from the requirements TXT. Then I execute my notebook. And I know that many people are already nervous, saying, oh, how do you do that? How do you do that? Let me skip it ahead and disappoint you. It's just one line of code that you're going to see that does that. And the rest is just framework stuff. And then in the end, I'll save the results back to a database. Are there any questions so far about that process?
No questions so far.
That's great. Then I'll just go on and show you some code. Okay. Let's get into the code. I'll minimize all this and I'll pull up my Visual Studio Code and show you the code that I wrote. Okay, so I'll walk through the code with you step by step. And I said it's 150 lines of code. And you can see that I wasn't lying. It's 150 lines of code. So first we install
Ben,
some...
just a small thing. Could you just zoom in because it's not quite visible
Zoom in
on
a bit
the...
further? Yeah, sure.
Yeah. All right. Thanks.
Is that better? Okay, so I'll install some dependencies, and this is where my function starts. And this bit here comes from the Azure Functions packages. And what it does, it's triggered by an HTTP request, and it returns an HTTP response. And what I do in my code is I'll walk through it with you in a moment now. So what it does first, I'll find out where my temp directory is located. And I'll pull from the environment of my Azure function some data like the repository I'm working with, the database server, the database name, the username and password for the database. And then I'll start by looking, where do I find the execution ID? So the execution ID gives me the information about which notebook I want to run. And I get that execution ID either from my request parameters, so from the URL. We have a parameter in the URL called execution ID, or I get it from the request body if it's a post request. Okay, so simple as that. We could simplify that and say, okay, we only accept GET requests, and we could lose a few lines of code. But here I would like to be open to both. Okay, so I get the ID of the execution that I want to, of the notebook that I want to execute. Some error handling. And now comes the interesting bit. I open a database connection and I say, okay, select the notebook execution, the ID that I passed, and give me the parameters that I want to run it with and the Git branch that it's located in. So this is where I get the metadata, the information about what I want to run. Then the next thing that happens is I check, is there a branch given? Did I get a branch name? This is also, again, error handling. We could lose all that. And then what I do is I clone my Git repository. So I get the URL of the Git repository. I get a local directory that's in my temp directory. And if it already exists from previous execution, which happens if I execute locally, I remove it. And then I clone, using the Git library, the repository from the URL to my local directory. And I check out the branch of the notebook that I had in my database. So if I wanted to change the way this works, if I said, okay, I have an entire repository per notebook and I always use the main branch, then what I could do would be I'd just change the clone URL to be something that I get from the database. So it would be very similar. Okay, next thing I do is I check if a requirements txt exists, and if so, I call pip install. Okay, I install the requirements. And after I've done that, and now comes the part that might be a bit disappointing, because what happens now is the magic happens. And I do some name handling, renaming stuff, finding the notebook. I loop the notebook, so there might be more than one notebook in my repository. And this is the one line of code. Well, I've split it up to several lines, to 4 lines, but you could write it in one line that does all the magic. This is the line that executes my notebook. And PM was something that I skipped over on purpose before, is Papermill. Papermill is a really great tool, a really great library to execute Jupyter Notebooks. Now, what happens if you execute a Jupyter Notebook? The result that you get is, of course, again, a Jupyter Notebook, but with new or with included results cells. So your Jupyter Notebook, if you think of your notebook as the collection of the cells, if you run the Jupyter Notebook, you'll still have a Jupyter Notebook. And in the new Jupyter Notebook, you'll have cells containing the results. So basically, that's what changes if you run a Jupyter Notebook. And so what I do, I run execute notebook, and execute notebook is handed, as you can see in the pop-up here, an input path and an output path. So the input path is the notebook that I checked out from the Git repository. And for the output path, I chose a new file name just so that I don't overwrite what I've done before. So I just append output to the file name. Okay, and after that is done, it's just wrapping it up, and that's fairly simple. Because what I do is I open the output file, I read the contents from the output file, and I insert that into my database. Simple as that. That's the entire process that happens here for me to get my data to my results to my database. I just for now I just grab the entire notebook and write that to the database. I also have a different endpoint. See it on the left here, result writeback, where I've written a method to persist a single pandas data frame into a database in order to be able to work with that. But this is a matter of a different presentation and not for today, I think. And what we've done now is we've gone through the entire process. And as you can see, it was 150 lines of code. The magic happened in 4 of these lines. And the rest is just setting everything up, installing the requirements, getting the notebook, handling errors, reading parameters from the URL, stuff like that. So this is the entire process that we have here in 150 lines. Are there any questions? I think, yeah, now that PowerPoint is gone, I can have a look here. Will this code be available for later reference? I haven't published the code yet. I'm thinking of doing so, but I have to check with my customer first. I have his go to present it. And if you look carefully, you can see everything that was done and everything is open, but I'm not sure if he's okay with me publishing the entire code on GitHub. I'll check that with my customer. Okay. Now let me talk a bit about, because I'm a data guy, let me talk a bit about data model as well. And for that, I'll go to the database with you. And I'll zoom in a moment. I can zoom in now. So I'm connected to my database, and my database currently contains 3 tables. So I have one table that contains the notebook definition. And my notebook definition basically has an ID, a display name, and that's for a front-end solution that is supposed to be sitting before that to make everything manageable for end users. It stores the information of the branch the notebook is in. I have the possibility to activate or deactivate notebooks so that I'm able to say, okay, I don't want to lose this this notebook definition, but I don't want to execute it anymore, so I just set it to isActive 0. It has an information who created the notebook, and it has a version string so that you can follow the versioning of your need. Okay, so that's a notebook definition. That's how I define a notebook. And now we come to this ominous execution ID that I kept talking about. I have an execution table. In my execution table, what I do is I basically queue a notebook for execution. So I say, okay, this is an auto increment column, the execution ID. And what I do is I add the notebook definition ID. So I say, which notebook do I want to execute? I pass parameters. This enables me to run the same notebook with different parameters at different times. And I have information for housekeeping, like when did I enqueue it and when was it finished executing, or was it a success? So this is basically the execution table. And what happens in my function, I pass that execution ID here at the top, and then I query that table to get the definition ID. I join that with the definition table, and I get the Git branch that I need to look at for that notebook. And finally, I have the results table, and the results table is boring because the results table just includes the execution ID, so I know which run was this that I'm looking at, and the result string. And the result string will later contain the entire notebook. You need to be a bit careful. This is varchar max, meaning you can store up to 4 GB in this column. However, I would not recommend to do that for practical purposes of database tuning. Okay, so now you've seen all the details that we have in here. I want to go back and show you one more thing, because the one thing is, another trick that I chose is I chose to deploy this function as a Docker file. And I chose to do so because this enables me to, for example, pre-install the ODBC drivers, to pre-install some requirements that are common in my customers' notebooks. And so I chose the approach to deploy as a Docker container, because this enables me to encapsulate some dependencies already, and this helps the function run fast. Because, for example, I don't think our customer has one single notebook that lives without data frames. So I can just install data frames with my requirements within my Docker container, and I don't need to reinstall it each time I execute a notebook. So I've made things a bit leaner in the process here, because installing requirements can take some while, and if you do it automatically and you sit there and you wait for a browse, well, it was basically, for me debugging, it was really annoying as hell to sit there and wait and refresh. Is it done yet? Is it done yet? Is it done yet? And that I remedied by installing pre-installing some requirements on my host. Okay, so these are the basics. Are there questions here? How about embedding the code in Databricks? Well, it's Python code. You can basically run it almost anywhere. I haven't tried running it in Databricks. I guess it might be possible, but I haven't tried so. So let's go back quickly and give you a quick rundown of the environment. Of the entire stack that we're working with. So the entire stack. At the beginning, we have our notebook. This is the culprit. This is what I want to work with. Next, I have a Git repository, which I host on Azure DevOps. But of course, you could also host it on GitHub, GitLab, whatever you feel like. You could choose any other solution to access your notebooks and to store them. For me, this seemed the obvious and most simple choice. I have one Azure SQL database for storing the metadata. I just showed you how the metadata looks. And then I have my Azure function. And the Azure function is implemented in Python, as you saw, and uses Papermill library for notebook execution. And Papermill also has something which I didn't show so far, which I didn't mention so far. It has parameter injection. So Papermill basically enables you to have a special cell, and you add a tag to that cell saying this is a parameter cell. And then later you can inject values from outside by passing a JSON array, a JSON object. And this will be injected in the cell that you tagged as parameter cell. That means you have the possibility to do stuff, for example, like changing from dev to prod environments by injecting new connection strings. Stuff like that would be possible, or running certain notebooks with different sets of parameters to achieve different results. And you could do all that automatically by adjusting the parameters that you pass to your notebook. And once the process is run, I have the Azure SQL database for storing the results and the serialized models. What I'm going to do now, I'm going to skip out of PowerPoint once again, and I want to show you all of this in action, because I think talking about code is okay, but seeing the results of running code is much more interesting. So let's have a look. What I need first is I need a execution. So what I've done, I've added, I'll zoom out a little bit to give you the overview. I've added two notebook definitions to my table. So one is a Hello World notebook, and one is an example for data cleansing. And I'll just show you how to run the Hello World notebook. And I hope you all believe me that the data cleansing example works just as well. So this is my notebook definition. If I look at my results table, since I didn't run the notebooks yet, my results table is empty. Not very surprising. And if you look at the notebook executions, there's no notebook execution scheduled. So I'll just insert a notebook execution. So what I'm going to do here is I'll insert into that table, into the columns enqueue time, because that's the time when I enqueued everything, and into my column notebook definition ID. And the notebook definition ID is the ID here. So I say, please execute notebook number 1 whenever my function is run. Okay, so I'll do that now. After I've done that, I have a notebook's execution ID, which is number 2, because I didn't reset my identity column. And you can see that I enqueued notebook number 1 at 12:35, so 11:35 UTC, into my table. So my execution ID is 2. And what I'll do now, I have my function deployed to Azure. And this is a bit, I'm afraid I cannot zoom in much more. I'll try my best to enlarge the font size. But with Postman, which I use to test my API, I'm not able to zoom in on everything. So I'll zoom in like this and hopefully show you in a moment. Oh, that was a bit too much. I'll zoom in like this and show you that this is the call that I do. So here you have my Azure function, notebook execution demo that I deployed for you. The function itself is called notebook automation, and I call it with an execution ID, and the execution ID I want to execute now is number 2. So I'll run that, and you'll see not very much happening here, because basically what you can see is I'm waiting. My request has been sent, and I'm waiting, and now I get a success message. So apparently my notebook was executed. Now let's check the database. Okay, so I'll check the notebook execution table. And you can see that the execution now has an end time and has a success flag. So apparently this notebook execution was successful. And now let's look at the results, because now the results table should contain data. And it does. And if we look at that, and that's one thing I want to do, because I think it helps to understand how a notebook is built. So I'll just paste the result from the table here. I'll have to zoom out a little bit because I can't access my Here you go. I'll zoom in a moment again. I'll switch to JSON. And this enables me to format my document automatically. And now I can zoom in again. And I'll show you some of the stuff that happens here. Okay, so we have a code cell that basically comes from, contains paper mill information and is tagged as injected parameters. So this is where paper mill would inject the parameters if I had given any. And you can see them here. I pass the parameter automatically, and that's the execution ID. I pass that automatically because I want my notebook users to be able to use this if they want to write back results to the database from their notebook at a later point. The next, you see a cell that's a markdown cell and just contains the text "Hello World." And next, you see a code cell. And you can see that for this code cell, we have information about when it was executed and how long the execution took. We get paper mill information about the duration of that cell. And our source was print hello user group. And our output, very little surprisingly, is the text hello user group. So you can see that apparently my notebook was executed. We can try again. If you would like to, then let me briefly go into my, okay, now I've created an infinite loop. No. I'll zoom in, and this is a bit spontaneous now because I hadn't prepared to show the things that I'm changing now. So I'll just go to my project, to my notebook execution project, to my repository. So this is my notebook execution repository. I'll zoom in. Hang on. I can zoom in the browser, much better. Okay, so I have my, I can choose my branch here. I go to my Hello World branch, and my Hello World branch contains my Jupyter Notebook. And as you can see, there is no result for this in my for this cell. I'll zoom in even further. For this cell in my Azure repository, in my DevOps repository, in my Git repository, and the result was added to the notebook when executing. So apparently this did what I wanted it to do. We can, let's just be a bit crazy. And edit this here and say, I just changed this to good evening user group. Hello, good evening user group. I'll commit that. Now I've changed my notebook. Now I'll enqueue another execution of that notebook by running another insert, saying again, I want to run the first notebook because it's still in the same Git repository. So I'll execute the same notebook again. If I do that, then in notebook execution, I have two executions. I have execution 2, which was successful, which just ran, and I have execution 3. Now I run execution 3 from, not from PowerPoint, but from Postman. I run version 3 of that notebook. It's running, and success. And if I look here in my database, I again have a success for the execution ID 3. If I look at the results and I pull the results for execution ID 3 and I put that back into my Visual Studio Code and format my document. And since this is a demo I didn't rehearse before, I hope that it really worked. Yep, you can see that in my output, now you see the text, good evening user group. So apparently I was able to run the notebook that was in the repository because that's the only thing that I changed. you all watch me while doing this. So this is basically the proof of concept that this entire workflow works as I designed it. I'll look if there's questions. Oh, no questions. Okay. If there's any questions or comments about that, I'm always more than happy to have questions, discussions, comments in the chat. Because what I'll do now is I'll pull up my conclusion, and then I hope that we have lots of comments and questions, that you have many things that we would like to discuss about what I've showed you. And so let me pull up my conclusions and get to that for you. We've looked at the stack. So the conclusion, the summary is, I honestly don't think that this is an ideal solution. Honestly, I'm not very convinced of running Jupyter Notebooks automatically, even worse, in a production environment. And that's just the way I see it. So it's not ideal, but, and that's something I have to say, it works. We've just seen it work. It even works with more complex notebooks, but the problem with more complex notebooks is I install requirements and the entire demo takes much longer and involves much more waiting. And I think you watching me waiting for a solution to run is not so entertaining for Tuesday evening. So it does work. And what's most important, the customer is happy about the solution because it enables him to do something that he wasn't able to do before. Do I like doing this in production? No. Do I know of a better solution? Unfortunately not. So if any one of you knows of a better solution, I'd be more than happy to hear any ideas you have about how to do this other than running the Jupyter Notebook. Of course, this means that you as data scientists have to be careful about checking in the repositories without the notebooks without the result, that you as the data scientists will have to be extra careful with not accidentally having delete or drop statements in your notebooks that might damage production. Because basically, of course, you can have a CI process with a review process installed in there. But let's be honest, mostly when we do it this way, it comes down to you running code on production, and that means you need to be extra careful of what you put into that code. However, it's not like, let's say in the olden days where you run in production means running on production server and thereby blocking everything else. This is not what's happening. But I'm sure all of you know that you can block a production server, a production database, a production table by running selects or by running inserts or by working on the database. So I ask you, if you have the need, just as I had, to do this, please be extra careful what you do and be mindful that you're working in a production environment and that you might break things if it goes wrong. So now what I would like to do, but I'm not 100% sure how to do it in this platform, is I would like to stop sharing my screen, keep sharing my camera, and go through any comments that you have. And thank you for spending Tuesday evening with me already.
So I had quite a few questions, Ben.
Yes.
Now, especially when you run into errors in your Jupyter Notebook, I've, at least, in the past, I've seen, Papermill run into issues while handling some of those. How have you handled that in your code repos as well?
Error handling. I have done. I've done in the solution that's in the solution that's deployed with the customer and that I've stripped down for this presentation. I have a bit of error handling. One thing is that I just log the errors the same way I log the results. And the second thing that I do is that I I didn't run into many issues with paper mill so far. The issues that I've run into is that I found one plotting library that didn't work that my customer was using. So I was very lucky that there weren't too many issues. But I'm aware that there might be more and that might cause issues. So as far as that goes, what I do is if there's libraries that are actually causing problems, I'll try to work around. Or if it's, for example, for that one notebook, it was a plotting library, and plotting doesn't matter to me in this context because what I want to do is I want to work with data not in an interactive way. So what I've done, I've created a wrapper around that library to just not call the library, and thereby and included that in my Docker container, and thereby resolve that problem.
Okay. Then when you kind of ended up picking Jupyter Notebook, I know you kind of gave a background on there. Why wasn't an option of converting the Jupyter Notebook into just Python code and using that and working through that? I mean, it's fairly straightforward. Were there any constraints that that stopped the client from making use of those?
There were basically two constraints, and one of the constraints was that the staffing, there weren't so many people who were able to do that, and there was high pressure on getting new notebooks developed. And so that would mean taking people who were able to develop the notebooks to convert the code, or it would mean, as an alternative, to have a data engineer, and there is only one data engineer in that group, transform the notebooks and thereby slow down the process of the entire project. And so that was the main reason why we decided that this was not the best way to go.
So if you had to go back and, kind of rethink this now that you have gone through this process, what would you advise the folks?
I would say it depends on the staffing that you have. If you have someone who's capable of converting a notebook into production-ready code fast, then that's the way to go, definitely. I would never run a notebook in production or in a daily process if I had a better solution and a feasible solution. So if you have the staffing that allows you to rewrite the notebooks, then rewrite the notebooks. However, if you're at the starting point where you have like 50, 60, 70 notebooks, and you have people outputting notebooks faster than anyone else can convert them, and you have two possibilities: to stop creating new insights and stop the data scientists from creating notebooks, or stop working on your development to convert the notebooks. Then if those are the alternatives, then it might be a good way to do it like I did.
Oh, that's a pretty good point. But one thing that kind of struck out is Paper Mill was made by Netflix, and knowing Netflix, they have like thousands of resources, and despite that, they use this internally, which I think 2016 is when they kind of, or 2016, 2017 is when they kind of made it open source, right?
So they had a similar problem, that they were producing more notebooks than they were able to convert.
All right. I'm just waiting for any other questions from the group. I think there is a lot of latency today. So, there's about 5 to 10 second delay by the time we speak and we ask for it. So guys, folks, if you have any questions for Ben, either post it or let me know on chat, and I can ask them for you.
Yep. Also, I hope that at some time travel restrictions will be removed and I'll be able to talk to you without latency.
I sure do hope so. All right.
Yeah, but I found that paper mill is quite extraordinary because it works really well in many scenarios. There are scenarios where it's causing problems, but it works well for many scenarios.
Cool. I mean, this is the first time I have seen, beyond what people talk in the Netflix community, that they have used paper mill. So yeah, pretty cool.
Yeah, it was a bit of a weird idea, but somehow it worked out. And as I said, the customer is happy, and that's what's most important.
No, I think a lot of companies don't want to implement it because they don't want to be the guinea pig. And I mean, again, paper mill was something that we, in my role in Property Guru, we evaluated it, but didn't feel comfortable using that. I guess after your demo, I think that gives us another vote of confidence that yeah, that's something that can be used for production as well. Though
It's at
more
least
often,
worth looking into.
yeah.
I would say that.
So you have another person from Germany, Kevin.
Yep, aus Berlin.
So Kevin came as joined us, and I think he's doing his thesis on multi-arm bandits. And a few sessions back, we had done a lot of multi-arm bandits, and he was pretty active with the questions and everything. So I think he's doing his thesis now. So
Very good.
and then we have Ankit also, who joins all our sessions. So we have a few regulars.
Cool. Yeah, I hope it was interesting for everyone. My contact information is on the slide, so feel free to reach out if there's any follow-ups or questions that you have. I'm always happy to answer those.
Let me just flash your slide. Maybe if you can do full screen, I'll keep it active for a moment.
Yeah, sure. Hang on.
Manisha is like, use Azure Databricks, a much smoother option.
Yes, it depends on what you want to do, because in my experience, I like working with Databricks, but Databricks is quite an expensive option as far as Azure goes, and I'm having a bit of pain if none of the notebooks really utilize the cluster and the Spark abilities, then to have a Spark cluster running for Databricks, it's not really necessary, just because of the costs it involves. And then if I think about processes where I want to run a certain notebook every hour or something, and you have like spin up of the cluster you have to include, then all of a sudden you reach limits where you say, okay, maybe it's not feasible to shut down the cluster between the runs, and then you have a cluster running all day for just tiny jobs, and somehow that it felt wrong for me for that customer. I've done Databricks with other customers, but for that customer, it felt wrong to have an entire Databricks cluster just for a few notebooks to be executed, some daily, some hourly. It felt wrong.
And especially if you have to manage that clusters, that's not fun.
Yeah, but fortunately with Databricks, there's not so much management involved, but still, again, in your daily load, also accounting for spin up times of the cluster and everything it's feasible, but it felt oversized for what the customer wanted to achieve.
Are there any other questions from the community?
Okay, this is if I present this to database and SQL guys, it's always a bit different question, a bit different process, but
No, I think it was pretty useful. So I'm going to kind of keep this video active, Ben, and I'm going to tag it with timestamps and everything. So I think this
yeah,
will be available for a while.
great.
Cool. Thanks a lot. We really appreciate your time. I know you are pretty busy throughout the day, so thanks for taking time in your
No
afternoon
problem.
to come and talk to us and share your knowledge with us.
Always happy to share, and thanks for inviting me. And as I said, I hope it was helpful for someone. Feel free to reach out, and I hope that someday I will get the chance to visit you and give a presentation in person.
We would love to host you. I think probably people would love. I think a lot of them would love like a hands-on session. Like tell us step by step how to kind of work through that. So
Yeah, that's always also going through code is a bit difficult if you're doing it online.
no, that's true.
So
Hopefully the travel restrictions subside and we are able to host you in person.
I hope so. So thanks for having me around, and thanks everyone for your time. And have a good evening or have a good day if you're in Germany.
Thanks, Ben. See ya. See ya,
Bye.
guys. See you next week. Next week we have another MVP coming as well. So it's again a fun session, and then just make sure you subscribe to the channel. So when we go live, you get the alerts and the notifications as you go along. So until next week, see you guys, and I'll see you on Tuesday. Bye bye.
Bye.